Okay, year 8. So I wasn't really happy with the detail they went into in the law of reflection, so I'm going to just cover another couple of things I think we need to think about. You will do a lot more of this in year 10, and if you do physics, you'll do it in year 11 and a bit in year 12. So let's cover some of it, and I'll give you some extension bits and pieces to look at, but know that what I'm giving you in style is what I'm expecting you to do on the test. So the law of reflection, so the angles coming in and going out of our light rays are equal. So you might maybe have to draw a diagram. So you're going to use a pencil and a ruler, and then you're going to draw a diagram. And I can make you do this because our assessment's going to be when you come back face to face. So this is more than likely something I'm going to make you do just because I've not really been able to see it and it's quite hard to do online. So I'm using pen because the pencil wasn't really coming up, but you would always in this case use a pencil. So our law of reflection. So there's some things we're going to show on this, and we need to have something. So this straight line with these lines underneath is my mirror. This is the shiny side, and then this one underneath is like the matte side, the non-shiny side. So we show the sides like that. The diagrams they gave you on style didn't show that, and I think it's clear that you have this because this is what I'm going to want you to do. So we have then our normal line, normal, and that's at 90 degrees. So I'm not going to expect you to be necessarily using a protractor to do this. We will use protractors when we do our pracs and things, but when we're just drawing them in a test, you're just going to label them, and then that's as is. A VCE, our diagrams are not to scale, so I wouldn't expect you to necessarily draw them to scale, but you're going to have to label them in such a way that you're showing me your understanding. So we've got whatever our light source is here. Let's say it's a candle. Oh, that's my drawing of a candle. It's mainly this. Yeah, there you go. A candle, and we've got a light ray coming in. And then that's coming in from, let's say, the top. And it comes this way, and we show it with an arrow going that way. So we show the light is coming from that object. We can have 1, 2, we can have one just at the end, but I think it gets messy if you have it at the end, so I quite like when you have them along the line. It keeps everything out of the kind of business end. And whatever this angle is here is our... So this is our instant ray. I mean, still trying to... So that's our light in. So that's whatever is being shined on the mirror. The mirror here, some light is being shined from our candle. And this angle here, I'm going to change colours because it's getting confusing already, is our theta incident ray. So our theta is this kind of curly 0 kind of thing, and that's our incident ray. Then we've got our light is going to bounce out at exactly the same angle. So again, don't need to show it. You want to kind of approximate it. It would be silly if you did it there. That's going to go to an eyeball. And this is our reflected ray. And we show theta R. And theta I is equal to theta R. But the good thing as well, no, that's terrible. That doesn't even look close. So this is equal to this, even though my drawing is not great. So that one is equal to this one, which means that if we know this one here, this angle here, we know this angle, So then we know this angle, and so then we know this angle, because this one and this one must add up to 90 degrees. So if we know this one here is, let's say that's about 45 degrees, that means this one's 45, that one's 45, that one's 45. So we can use this property to work out, you know, lots of things, you know, where we can stand to see the light, lots of other things. So that's the first bit. So our next step is going to be looking at our reflective rays and how we can see our images. So this is just a very simple, this is the law of reflection. Then now we're going to look at our virtual images, real images, and line of sight. And so we're going to now look at, will we be able to see an image, and virtual images. So we have our mirror, nothing's to scale. Label it, but this symbol says that's a mirror. And we've got a person stood up here. Very often we use things like people, or very simple things. People. We can also, sometimes they show an arrow, because that's got a very obvious top and bottom and doesn't rely on your drawing skills so quite so much. So we've got a person, and then we've got you looking at a mirror with your eyeball. So we've got an eyeball, we've got a person looking at the mirror. Another person stood by the mirror. Are you going to be able to see them? What kind of images are you going to get? So this is our actual images. So this is our object. This is our kind of real image, I've heard it called. That's our real image. That's our actual thing in the actual world as it looks. So we have this guy here, and the light from him is coming down like that. So using our, we've got our normal coming here. Oh, that's meant to be dots, that didn't work very well. Normal. And then whatever the angle is, I've drawn these too far up. Change my eyeball. So because this is my theta I, my theta R is the same. Theta I, theta R. Because this is the same, that bit of light is going to hit that eyeball there. But our eyes aren't made for mirrors. We didn't evolve with mirrors. Our brain does a lot of our sight for us. It's a strange and fascinating thing. So what's actually we can see is we have this projected forward. So what we see is that going forward, and it goes out the same distance as here. So that's about here. Again, my angle's all a bit off, so it's all a bit wonky. And then we can see here that top of the head for that guy. So this is my virtual image. Because he's not really here, but it looks like, when you look in a mirror, it's the same distance away from the mirror. So if you're 1 meter away from the mirror, you look like your virtual image looks like it's a meter away on the other side, but you're upright. You're upright over here. So then we can do the same for our feet. So the feet, that angle comes down like that. Made him too big. That goes down there. It's my normal. So this guy here isn't going to be able to see this guy's feet, but this guy will be able to see the feet. And again, we can project that forward. And that goes in to his feet. So his virtual image here. So again, we're just using those laws we learned about earlier. So that angle to work out who's going to be able to see this guy here. And it's going to be about just you being able to sketch our real image, a virtual image, and then people being able to see it down here. So I've seen questions where they have, you know, several people and who can see the candle or who can see the apple or whatever the drawing is. That might be the kind of thing you have to look at. So I think we're going to cover some more of this when you get back, because I want to be able to see you actually do it by hand. I think it's quite hard to do it online, but you'll think about this when you're doing some of those interactives, and think about how you might do something around this maybe with your research. So that's our real image, virtual image. Think about it next time you look in a mirror while you're washing your lovely hands.